Hello, welcome everyone. So this is a very special, very short lecture that I'm going to be talking about, which is going to be talking about a very special and interesting topic. Yes, I'm sorry, I'm looking, anyways, the camera's there, but I'm looking there. Don't worry about it. So this lesson or this lecture is going to be about why 24 is a cool number. 24, cool number. If we don't think mathematically, one of the reasons why 24 is a cool number is because the 24th of June is in Quebec, the national the national day of celebration for Quebec. It's La Saint-Jean-Baptiste, which is a very special event for some people in Quebec. It's a place where you gather and you celebrate why Quebec is amazing, and why it has a separate national holiday in Canada. Anyway, so that's one of the reasons why 24 is cool. The other reason why 24 is cool is going to be the following reason. If you have a prime number, so let's have a definition first. So let's have a definition of a prime number. So a prime number, what's a prime number? A prime number is a whole number greater or equal to 2 such that it is divisible by 1 and itself only. Okay, so that's the definition of a prime number. What does that mean? What does that mean? Well, that means, for example, a prime number can be, so what's the smallest prime number? It's 2, right? Because 2 is divisible by 1, right? 2 divided by 1 is 1, and 2 divided by 2 is 1. So 2 is divisible by 1 and by 2. Also, I'm going to change color because this is a very poor choice of color. What's another example? Let's say, let's say 5. Okay, 5 is on the spotlight. Let's say 5. 5 is prime because the only numbers that divide 5 are 1 and 5, right? Because 5 divided by 2 is no good, that's not a whole number. 5 divided by 3 is no good, that's not a whole number. 5 divided by 4, that's no good, that's not a whole number, right? Okay, so that's the definition of what it means for a number to be prime. Oh, I can't change the color for this. Okay, so this was an example. Just gonna write so 2, just so you can see, right? And then we can like generalize. Well, we can't really generalize this concept. It's already generalized. It's a definition, but like you can go bigger, right? So you can think about what's a very large number that we think is probably prime. Let's say 19 isn't very large, but 19 is prime, right? If you think about it in your head and you think of all the numbers from 1 to 19, the only numbers that divide 19 are 1 and 19, right? So that's what it means. So that's what a prime number is. Okay. So now let's go back to our original point that I was trying to make, right? So I started with the concept of why is 24 a cool number? Then I went into this kind of rant about prime numbers. So what's the connection? What's the connection? Whoops. What's the connection? Okay. So the connection, and it's a very nice one, is take a prime number p, right? And for this sort of theorem or factoid to work, p has to be strictly greater than 3. So in other words, the first prime number after 3, right? So if we list the first 3 prime numbers, so the first one is 2, then it's 3, then it's 5, then this factoid is only going to start at 5. And there's a very good reason why. So if you take a prime number p, right, and then you square it, right? So you just multiply it by itself. So, right, so just a reminder, what is p squared? It's just p times p, right? Okay, so you take that prime number, you square it. And then you take that prime number square and you subtract 1. What happens? Well, it turns out that this number, which is whole, of course, right? Because squaring something doesn't make it not an integer. If it starts an integer, squaring it is going to still make it an integer. And then subtracting 1 is still going to make it an integer, right? So all of this is still a whole number. So whenever you have a whole number, then the interesting question that you can ask about it is, what is it divisible by? Well, it turns out that for any prime number p greater or equal to 5, p squared minus 1 is always divisible by 24. And so this symbol that I just wrote out can be read as is divisible by 24. Well, that's pretty interesting, isn't it? Because that's quite an interesting property. Because if you had put any other number, like say you had put 17, then that wouldn't have worked. Or if you had put 27, then that wouldn't have worked. If you had put 30, then that wouldn't have worked, right? There are a few other numbers for which this would have worked, okay? But 24 is an interesting one, and 24 works for every prime number p greater or equal to 5. This isn't, the other important thing though to note is this isn't an if and only if, right? So if a number is divisible by 24, it does not necessarily mean that it's equal to a prime square minus 1, right? So this is only the forward direction. So if p prime, then p squared minus 1 divisible by 24, right? But the other way is not necessarily true. So if a number is divisible by 24, it doesn't necessarily mean that that number can be represented by a prime square minus 1. Okay, but still, this forward direction is quite interesting. So let's examine it a bit. So we know that this has to start at 5. Okay, so let's see if it works for 5. So you take 5 squared, right? And you subtract 1. So what is that? That's 25 minus 1. That's 24. And that's obviously, 24 is obviously divisible by 24, right? Let me get my calculator, because it's a bit early in the morning and my mental math is a bit rusty. So let's think of another number. Let's do 17. Okay, let's see if I can do this over my head. So 17 squared is 17 times 17. So that's 170 plus 49. Oh God, 139. I think. So is that 209? Let's see. Did I make a mistake? 17 squared, 289. Whoops. Wait, how did I? 10, 177 times. Oh, did I mess up the? This is 119. I see. Oh, and I messed up the addition. I have a bachelor's in math. I have a joint major in mathematics. Okay, don't worry about it. Don't worry about it. Okay, so you get 289. And then subtract 1. It's 288. Okay, that doesn't really tell you much. All right, let me just prove to you. So I have 17 squared. 17 squared. Right? I square it. Let's subtract 1. I have 288. Okay. Divide 24. Divide 24. It's 12. It's 12. It's divisible. Victory. All right. So again, it works. And you can test it out with any prime number you like, and it's going to work. Okay. So why does it work? Why does it work? Let's see. Okay. So why does it work? Well, it's a very simple reason, actually. So, and this is actually the reason I'm mostly just copying a video by Brady on number 5. So he has another nice video that actually talks about the very exact same property. I just wanted to redo a video about it because I think it's fun and I think it's cool. So why does it work? Well, let's inspect the number p squared minus 1. Okay. So one thing that you can notice already from p squared minus 1 is that it's a difference of squares, right? So it's p squared minus 1 squared. And what do we know about difference of squares, right? So what do we know about a squared minus b squared? It's that it's the product of the sum and the difference of the two terms, right? So it's a plus b, and it's a minus b, right? So we have p minus 1, and we have p plus 1 here. Okay, so we know that p squared minus 1 is actually p minus 1 and p plus 1. So if we look at our number line, we have p, right? We have p plus 1, and we have p minus 1. Okay, right? Right. Okay. So what is this like sequence of whole numbers telling us about the nature and the divisibility of p minus 1 and p plus 1? Well, we know that p is prime, right? If p is prime and it's greater or equal to 5, we know that this must mean that p is odd. Why? Because if it weren't odd, right, if it were even, then it would be divisible by 2, and then it wouldn't be prime, and that's a contradiction, right? So we know that p is prime, which means that it's odd. Meaning, so, and we know that on the integer number line, like if you start at 1 and 2 and 3 and 4, if you're at an odd number, then to the left and to the right, you're going to have even numbers, right? So to the left and to the right, you have even numbers. So what does that mean? That means that p minus 1 is even, and that means that p plus 1, sorry, is even. Okay. So what does it mean to be even though, right? If a number is even, then by definition, right? So the definition, I'll put it on the side, of an even number. So a number, let's call it t, is even if and only if t can be represented by 2k, where k is some whole number. Okay, so that means that it's divisible by 2, right? So what that means is that p minus 1 is divisible by 2, and p plus 1 is divisible by 2. But actually, the interesting thing here is whenever you have a sequence of 2 consecutive even numbers, one of them is actually going to have to be divisible by 4. Okay, so let's take this example, for instance. So this first even number is divisible by 2 because it's even, but then the next even number is divisible by 2 and 4. And so whenever you have a sequence of 2 consecutive even numbers, one of them is going to be divisible by 4 and 2. So that's going to be very advantageous. So I don't know which one, right? It could be p minus 1 or it could be p plus 1. But what I do know, is that, so I know that p minus 1 and p plus 1 are divisible by 2, sorry. And possibly 4, right? And possibly 4. But I know for sure, right? I know for sure that one of them is going to be divisible by 4, right? And that's just, you can work it out by writing out what an even number looks like in the sort of first place, and what an even number looks like in the second place. So what that means, right, the result is that if I know that p minus 1 and p plus 1 are both divisible by 2, and one of them is divisible by 4, then that means that their product, right, their product is divisible by 8, right? Because it's just a way of multiplying something, right? If a number, let's say k, is divisible by 2, then that must mean that k is equal to k can be represented as 2 times some integer t. And if another number, let's say n, is divisible by 4, then that must mean that that number can be represented by 4 times some integer s. So then when you take the product of k and n, you get 2t times 4s, which is actually 8 times ts. And then if you just relabel ts, then you get 8 times, some other integer, right? Because t times s is actually another integer. It's, let's say, the integer m. So kn can be represented as a multiple of 8, meaning that it's divisible by 8. So p minus 1 times p plus 1 is divisible by 8. Okay, so we don't know that it's divisible by 24 yet, right? But that's our goal. But actually, what we can notice is if we go back to our number line, we have p minus 1, p, and p plus 1. We know that this number is even, this number is odd, and this number is even. We also know that this is a sequence of 3 consecutive numbers, right? So it's like if we have 4, 5, 6, right? So we have a sequence of 3 consecutive numbers, which means that one of these, right? One of these must be divisible by 3, because that's how sequences of 3 work on the real number line, consecutive sequences of 3, right? So you start at 4, right? 4 can be represented as 3 times 1 plus 1, right? That's 4. Then you go to 5. 5 is 3 times 1 plus 2, that's 5. And then 6 is 3 times 2, which is divisible by 3, right? So this is, whoops. Okay, I'm losing cooperation from my iPad. Oh, am I just losing power in my pencil? 70%, that seems sufficient. Okay, so this is 3 times 1 plus 1, this is 3 times 1 plus 2, and this is 3 times 2. Right? So then one of these have to, like, whenever you have a sequence of 3 consecutive numbers, one of them has to be divisible by 3. Which one is it, right? So which one of these 3 numbers is divisible by 3? The goal, right, ideally what I want is I want it to be either p minus 1 or p plus 1, because then it's divisible. We know that that product is divisible by 8, and then it's also going to be divisible by 3, meaning that it's going to be divisible by 24. But that's the goal. That's what I want to prove, right? How do I do that? Well, can p, oops, the Apple Pencil is not cooperating. That's terrible. So can p be the one that's divisible by 3, right? Well, no, because by definition, p is prime. So if p were divisible by 3, then that would be a contradiction. So p can't be the one that's divisible by 3. Okay, so then I've already established what I wanted. If it's not p, then it's either p minus 1 or p plus 1. So either and only one of p minus 1, p plus 1 is divisible by 3. Excellent. So what that means, if we go to the next page, what that means is we've shown that p minus 1 plus 1 is, it's divisible by, well, let's see, it's divisible by 2, right? It's divisible by 4. It's divisible by 8. And now we know that it's divisible by 3. And because of the last two results, this implies that p minus 1 times p plus 1, which is p squared minus 1, is divisible by 24. Excellent. And actually, you'll notice, and Brady even talks about this in his video in Numberphile, that we don't use the property that p is prime. We just use the fact that p isn't even and p isn't odd. So really, p could have been any number that, well, actually, I don't want to make a claim that I can't prove. But I'll leave it as an exercise to see if there's a more general class that you can sort of categorize this number, because I haven't said anything about what p really is, right? The only thing that I need p to be is I need it to be in a sequence of 3 numbers. It can't be, it has to be the odd one, and it can't be divisible by 3, right? And I'll leave it to you. There's a precise way of qualifying or quantifying that number. And I'm thinking about it in my head, but I'm not going to write it down because I don't want to write something down that's incorrect. And then people write in the comments, you're incorrect. 24 isn't cool, because 24 is cool, because the result of all of this, if my iPad were to cooperate, strange iPad, the result of all of this is that 24 is an amazing number. So if you're feeling depressed because you're turning 24, or you have turned 24, or maybe you just recently turned 24, then don't be, because age is just a, wow, this got very philosophical and very less mathematical. Age is just a construct, and 24 is an amazing number. So with that, I wish you to have an amazing 24th number, year, month, day, and see you for the next number.